All right, guys, we're going to go ahead and go through CFA 6.9, 6.10, and 6.11. Again, you've got your hard copies, so make sure you're writing these down so you've got something to study for the test, and also re-listen to the teaching here again as a review. All right, first, number one here, we're supposed to solve the equations using the inverse operations and that traditional strategy, and we're going to show our work and make sure we check it and be precise, okay? We know this is 5 times n, and to undo multiplying by 5, the inverse is to divide by 5. So if I divide by 5, it's like it never happened, and I'm just left with n, because those undo each other. And we know we try to balance this, so what I do to one side, I must do to the other. So I divide it by 5, kind of like that pan balance, right? You got to keep it weighted the same. So if you divide one side by 5, you got to do that to the other. So you get n equals 11. And again, I know a lot of you could have done that with trial and error, because you know 5 times 11 is 55. But again, just practicing that traditional strategy here. To check, I would plug it in. So it's 5 times 11. Instead of n, I plug in an 11. Make sure you use parentheses so you know that means 5 times 11 and doesn't look like 511. And that should equal 55. And I know it does. Again, we look and show that 55 equals 55. So again, proof, we know that we're right. So make sure you're double checking these every time, and you should be able to get them right if they work out. Okay, the second one here, we've got t plus 4 1/4. So to undo adding 4 1/4, I know I subtract 4 1/4, and that's like it never happened. So I'm just left with t. And if I do that from one side, I must do it to the other to keep it balanced. And I can do that mentally. 11 minus 4 is 7. And then take away another 1/4, I'm at 6 3/4. So go ahead and check that. T, we said, is 6 3/4 plus 4 1/4. And that does equal 11, because I know 6 and 4 is 10, and then 3/4 and 1/4 is one more to get me to 11. So again, double checking, just with one-step problems there, using that traditional strategy of solving to try and find a variable. Okay, so if you need to, you can pause the video to get this stuff written down. Okay, moving down here now. On number 2, I think I'll shrink this a little bit so we can see it here. Okay, so on number 2, our job is to tell the operation, explain the operation that's going on in each step. Okay, so if I look at the original equation, I've got 4x plus 20 equals x plus 29. And it looks like when I jump down, there's only 3 x's now. There's still plus 20, so it looks like they subtracted an x. And they also subtracted an x here because it's gone. So I'm seeing what they did in their first step is they subtracted an x from each side. And once they've done that, now we're going to look at that next step, and we've got 3x plus 20, and then it goes to just 3x. So it looks like they subtracted 20 to undo that, and they also subtracted 20 there. So the next step, they subtract 20. Again, we're trying to isolate that variable and get x by itself. So now we've got 3x equals 9. And on this step, it looks like we know for multiplying by 3, to undo that, I must divide by 3. Okay, it's not subtract 3x. Sometimes kids think they need to subtract that 3x. You're trying to get x by itself, so you don't want to subtract all of it. So if you're multiplying by 3, to undo that, you divide by 3, and you divide by 3 here. So I need to divide both sides by 3. And if you do that, you're left with x equals 3. And I can show that up here if I divide by 3, and this becomes 9 divided by 3. So x equals 3. And again, that's just solving it, kind of making it look like it's a pan balance, but again, we're just doing inverse operations and undoing things, okay? So again, pause this, we'll go look at the back side, make sure this is copied, and then we'll talk about the back side. All right, so this was from lesson 611, and on 611, we are solving the equations using any strategy here that we'd like. We'll probably just use the traditional way when you start getting fractions and you have to distribute. A lot of times that's what you'll do. All right, go ahead and enlarge this again. All right, so let's go ahead and take a look here and talk these through. We'll start over here with this one. There's a lot of ways we could do this to undo things from both sides, so you kind of got to study it and figure out what might be an easy way to do it. So I'm going to start with, I think I'm going to subtract this half w over here. So if I take a half w, half times w, which just is a half W. You don't have to have the parentheses there. We could write it just like this, which just means a half of a W. And I know if I subtract a 1/2 W, that it's going to be gone. I'm taking it away. And I still have plus 10. Okay, so that gets gone because I undid it. So I'm left with 10 over here. And remember, what I do to one side, I must do to the other to keep it equal or balanced. So here I had a W plus 6. Well, if I subtract a half W, I can do it right beside there. So I'm going to subtract a half W. But I still have the plus 6 from that. So if I take W and subtract a half a W, I still have a half of a W left. Okay, didn't undo it completely like over here because I started with a full. I'm taking away a half. I'm left with a half a W plus 6. And I know that has to equal 10 in this case. And I got to decide what to do next here. So again, I want to get the variable by itself. So if I add 6 to undo that, let's get that number out of there. I can subtract 6. So I'm just going to do that right here. If I add 6 and subtract it, it's like it never happened. So I'm left with a half of a W on this side equals. If I take 6 away here, I must take away 6 there. Okay, and if I take away 6 there, I'm left with 4. So a half a W must equal 4. So some of you can solve right here. If I do a full W, I'd have to double it. And I double it, and I know W equals 8. So you could think of it that way. But we think of this as multiplying a half times a W. Well, if I take a W and take it times half, to undo that, I can divide by a half. And that undoes it. So I must divide this side by a half. And we know dividing by a half is the same as multiplying by 2 if we use our reciprocal. So really, this is 4 divided by a half is the same as 4 times 2. So W has to equal 8. All right, so that's one way you could look at doing that. But again, several steps of using inverse operations there. Okay, let's plug it in. So W is 8. 8 plus 6 we know is 14. Let's plug it in over here. If W is 8, should do this mentally. A half of 8 is 4. 4 plus 10 equals 14. So I know I'm right. And it works out. So they both equal 14. All right, last one here. We're going to have to distribute first now so we can get this in a different form. So if I distribute here, it's 8 times R minus 32, because I know 8 times 4 is 32, must equal 4 times R plus 8. Because I got to take the 4 times the 2 also. Okay, so a little bit there. Looks like it's in the light a little, so I'll move it over a little. So 4R plus 8. All right, so let's take a look. How could I do this here? One way, when I'm going through this, if, let's say I'm subtracting 32, so let's add 32 to undo that. Leaves me with 8R. So on the other side, I must also add 32. And 8 plus 32 is 40. So I'm left with 4R plus 40 when I combine those two like terms there. Okay, next thing I would probably want to do is subtract 4R here because I want to get the R's all on one side so I can figure it out. So if I subtract 4R here, that gets rid of that, and I'm just left with 40. And if I subtract 4R from this side, 8R minus 4R, I'm left with 4R's. And now we know that's 4 times R. How do I undo multiplying? I divide. So I can divide by 4, and I'm left with just R. So I must divide by 4 on this side, and R equals 10, because 40 divided by 4 is 10. Again, let's go plug it in up here. Okay, should be able to do it mentally. 10 minus 4 is 6. 8 times 6 is 48. And that must equal, if I plug in the 10 up here, 10 plus 2 is 12. 12 times 4 is 48. So both sides equal. And I know that R has to be 10 in order to make this true. Okay, so again, make sure you've got these copied down. It's a lot of work and a lot of thinking that we did there. Okay, all right.